In the last episode, we learned how to configure the printHAT for a Cartesian printer. Today we're going over the configuration steps for a Delta robot. The printer has the same basic setup composed of the following hardware: one extruder, one hot end, 3 end-stop switches, one hot end fan, and one print fan. To get a boilerplate configuration file, open the browser and navigate to the printHAT GitHub repository. Click on the printer.delta.cfg file and then on the Raw button. Select all the text and copy it to the clipboard. Navigate to octopi.local, which will take you to the Octoprint dashboard. Click on the small wrench icon in the top menu to open the setting panel. The RecLab image installed in the previous tutorial comes with Klipper, a plugin that automates and simplifies some of the day-to-day Klipper tasks. Scroll down to the end of the left panel and click on Klipper to access the settings section. Then click on the Klipper configuration tab at the top to open the text editor for the configuration file. Delete all the existing content and paste the file content copied from the repository. The content starts with the configuration parameters for the stepper motors on the motion axis. For the Delta robot, this corresponds to the A, B, and C columns. Only a few of the parameters needs to be changed. So let's have a closer look. Position end stop. This is the distance of the nozzle above the bed when it is centered and the end stops trigger. Dir pin. This is the parameter that defines the direction of movement. There's no way to tell in advance if the column will move in the correct direction. If you happen to have inverted motion on the first time you will home the printer, come back here and add an exclamation mark before the pin name. Step distance. This value is the distance the column will travel for each step of the stepper motor. It is the reciprocal of the steps per unit used by the Marlin firmware. If you know the correct value of the steps per unit from Marlin or from an online tool like the Prusa RepRap calculator, take 1 over steps per unit and put the result in the step distance parameter. Arm length is the length of the diagonal rod that connects the tower to the tool head. As for the position end stop, you should take a measurement directly on your machine. Moving on to the next section. This is where the configuration parameters of the TMC driver are stored and doesn't require any change. You can come back here later if you need to increase the maximum current that the stepper driver can deliver. The next 4 sections are a repetition of the above for the B and C columns. Next up is the extruder section, which stores the parameters that describe the extruder and the filament characteristics. The dir pin defines the direction of extrusion. If you happen to have retraction on your first priming, come back here and add an exclamation mark before the pin name. The step distance indicates the length of filament extruded when the extruder motor turns by 1 step. Again, the value is the reciprocal of the Marlin steps per unit, so the same 1 over steps per unit formula applies. If you don't have the number available, you have to calculate it knowing your extruder setup. Set the nozzle diameter to match the diameter of the nozzle in your hot end. Do the same for the filament diameter. Then, for the sensor type, you have to pick the correct model from the list of sensors supported by the Klipper and insert the name without quotes. The temperature of the hot end is best regulated using the Klipper PID controller. The provided value should be a good starting point, but it's strongly recommended to run PID calibration as indicated in the Klipper configuration checklist to avoid hot end problems and achieve the best performance for your setup. The next section to update is the one that contains the configuration for the heated bed. As done for the hot end, you must set the correct sensor type, picking the name from the list. The last section in the configuration file contains some general printer parameters. Here you can set the maximum speed and accelerations the printer can reach. These are R limits imposed by the firmware, which means that the printer will not perform faster even if the G-code commands ask Klipper to do so. Finally, the delta radius has to be set equal to the radial position at which the 3 towers are located. This value can be calculated knowing the geometrical characteristics of your printer. When done with the configuration, click the Save button at the bottom right of the page to save the new configuration file.